Today's lesson is on section 8.2, apply exponent properties involving quotients. In the first section of this chapter, we've applied exponent properties using products. When we're multiplying things together, what can happen with powers, what's the way we can simplify them. Just kind of reviewing those three rules that we've learned so far. We kind of got three rules, or again, three things that we can use to simplify a problem. Just like when we used to combine like terms, this is something we can use to simplify things with powers. So here are those first three rules, just a very brief reminder. Product of powers rule, if I'm multiplying two powers together and they have the same base, well then I can just add the two exponents together, because it's really like 2 5s multiplied together and then 7 more 5s multiplied together, so it's like 9 5s multiplied together, so I just add those two together. If I get a power to a power, like the second one, like 10 to the second power and then that to the 7th power, we found the rule actually says I can just multiply those two powers together, and this is really just like 10 to the 14th power is the way I can do that one. And then the other part, 8.1, that shows this third rule. We're going to deal with things in parentheses this year that have a power, but when all these things are multiplied together, all these things 4a and b, when they're all joined by multiplication, then I actually can apply this squared power to each thing. And again, sometimes I say that word distribute to maybe think about what's happening, how to apply that power, but I know distribute isn't actually the right word. Let's just say apply instead. So I'd apply that power to each of those, and it'd be like 4 squared, a squared, b squared. So I have showed us those rules from section 8.1. When things are multiplied together, there's a few rules we can use to simplify a power. Now jumping back to section 8.2 though, the new section. So if you apply exponent properties using quotient. So what if quotient means I'm dividing powers. So what happens when I'm dividing two powers? What can happen? Well, again, first I'll just kind of make this connection too, like the problem we just recently did. If I had 5 squared times 5 to the 7th, what happened? I end up adding those two exponents together, and I am just getting 5 to the 9th, correct? Well, keep that in mind for now that we're dividing powers, what may happen with our exponents. But first I'll show you a little bit of the behind the scenes, like why does this work out? Well, let's look at this problem. What if we had 4 to the 5th divided by 4 to the 3rd? Writing this out in product form, 4 to the 5th would just be 5 4s multiplied all together. And 4 to the 3rd would be 4 3s multiplied, 3 4s multiplied all together. Well, remember in a fraction, if we have a factor on the top and the bottom that are multiplied together, we can actually cancel these out. So if I cancel some of these, I can cancel a 4 on the top and bottom here, and another 4, and another 4. And what would I be left with? Well, I'd just be left with 2 4s multiplied together. So, and just on the top, so that'd be 4 squared is what I end up getting for that. Well, then I'll ask students, well, can you make the connection here? Think about what we've already done with products, but can you make the connection? What happens if I am dividing two powers that allows me to just actually shortcut and simplify to just 4 squared like this problem? Well, then usually they can figure out, well, if we added for when we're multiplying powers together, we can just subtract these two exponents and get 4 squared. When I'm dividing and I have the same base number, again, that is important though, I have to have the same base here. If I have that same number for my base for my powers, I can just subtract the two exponents. So as always, if you're taking notes along with me, that's the first rule I'm going to show you here today. And here it is. So copy that along down with me, or in your notes. Quotient of powers rule. Quotient means I'm dividing things. And powers are, again, powers like things with exponents, right? Like we've been dealing with. So yes, it says if you're dividing powers and they have the same base, like that example has m for each one, then I can just subtract the two exponents, and that's what my power will be now, to simplify it. So again, we may simplify this just writing. It might say simplify for the directions. It may say write as a single power, or write using exponents, it may say. But all it's asking us to do is apply this rule. 8 to the 9th divided by 8 to the 4th. I just keep that same base and subtract 9 minus 4 and get 8 to the 5th power. Same thing with the second one here. It's a negative number for my base, so I got to keep that negative 10 in parentheses, as I've talked about before. If you punch it in your calculator too and try to evaluate that, you do also need to keep it in parentheses, otherwise your calculator might not evaluate it correctly. So if you have a negative number for a base, you're taking it to a power, keep that in parentheses, even on your calculator. 21 minus 13 gives me 8, so negative 10 to the 8th power. Looking at just a few other ones below here. Number 3, this one will use a combination of some of the rules we've learned. Notice that there is dividing in this problem, but on the top, I can deal with this part first, right? We learned a rule for that in section 8.1. Y to the 4th times y to the 7th. When I'm multiplying, I add the two exponents together. So on the top, now I've got y to the 11th power. And after I've simplified that top part, now I've got y to the 11th over y to the 6th. I can use the new rule from today and subtract the two exponents. And so now I got y to the 5th. So using a couple different rules. As you'll see, and as we go on here, that's going to be kind of the trick. Each rule by itself is not too complicated. There's only one step to it, maybe adding or multiplying numbers or applying a power to each variable or number. But the trick is now, can you use them in a problem to do a couple different simplifying moves, or a couple different things to simplify that problem. Number 4, you'll see some of these in the assignment, and once in a while maybe on a quiz or something too. And they're just almost ones that are just little ones to try to trick you, but it's still something you can definitely understand. It has a fraction here for this first one, 1 over g to the 4th. Okay. Well, don't be too fooled by that and wondering like what we should do with this one. To help out, it's multiplying by g to the 9th. But what I could do is I could write g to the 9th as a fraction also, right? I could actually just write this as g to the 9th over 1. So now they're both fractions. That may help a little bit. Remember, when you're multiplying fractions together, you just multiply the tops together and the bottoms together. So this would end up being g to the 9th over g to the 4th. And now that I've got it just in one fraction, you can see it's just like our rule from today. So I subtract the two exponents, g to the 5th. Two more examples here I'll talk about at the bottom of this page. This one has a couple different variables in number 5. It's got x and y in it. And again, they're on top and bottom. So far today I've showed you the rule, well, going back up to like, let's say number 1 here even. So if I have the same base on the top and the bottom, I can just subtract the exponents, right? Well, now I've got two different bases. I've got two different powers there. I've got x to the 7th and y to the 4th, but you'll find out, and I'll ask students usually, but we'll start to figure this out, or I can show us, that we can actually just treat each one separately though. Each one that has the same base, I can combine those or simplify those. And so I'm just going to kind of split it right down the middle and realize that I can deal with the x's separately and see what I get there. And then I'm going to deal with the y separately and see what I get there. So x to the 7th over just x. And remember, if there's no exponent written with a variable, it is like there's a variable of 1 right there. So x to the 7th over x to the 1st, if I subtract those, I get x to the 6th. And then same thing with the y's. I'm just going to deal with those separately. So y to the 4th over y squared, if I subtract those, I get y squared. So just know I can deal with each one of those variables separately and then get a simplified answer for both. This last one here on the page is a little different though. I still can split it down the middle and think about it. And so I can deal with each thing separately. And I think we know now, okay, from this page how we can deal with these ends. End of the 9th over end of the 4th would give me end of the 5th. But just be careful, because I see this mistake very often though. The other side, these aren't powers, right? These are just numbers out front. These are in this case, I guess, coefficients for our ends. Okay, so those are just numbers. Those are still gonna. We're learning rules that can help us deal with powers and deal with exponents. But the 8 and the 2 should still just apply to the same rule they always have. This line means divide, right? So it's just like having that fraction, 8 divided by 2. So what would that give me? That would give me 4. Okay, so those coefficients, and sometimes I just say big numbers out front, but really I should say coefficients. So the coefficients, those just follow the same rules like we've always done with math. So there's a division line there, so I'm just going to divide those or reduce those like a fraction. The powers are what we're learning special rules to reduce or simplify. So that's where I'm going to use my subtraction rule. But the 8 divided by the 2, that's just going to become 4 in my problem. In this section 8.2, there's one more rule we can learn about applying exponent properties with quotients when we're dividing things. It actually is very similar to the last one we learned in section 8.1. Remember, if things are, I talked about this rule, if things are multiplied together, I talked about this in the previous lesson, Really, that x and that y, I could put a little dot in between and think that those are multiplied together. If those things are to a power, like this 2, outside the parentheses, it's saying take both those things squared. Remember, I can apply that power to each one of these, right? I can apply it to the x and apply it to the y to the third. So what's going to happen? Well, x will just become x squared when I apply that power. And y to the third to the second power is a power to a power. That's the second rule we learned in the first section. So that'd be y to the 6. But if I have things that are multiplied together inside of parentheses and they're to a power, I can just apply that power to each of them separately, correct? Well, the same thing can happen, just like our first rule, how it's similar to products. The same thing can happen when I'm dividing two things inside parentheses and they're to a power. So same thing here. This is 3 divided by 2 to the 5th power. Well, I can just apply this 5th power to each thing in the top and the bottom of my fraction there. And I'll get 3 to the 5th over 2 to the 5th. And that's how I can apply that power to each thing that's in there. Same thing with this next one. So I have x over 7 to the 4th power. So again, just like yesterday when I had things that are multiplied together in parentheses, I can apply that power to each one. Same thing when they're divided. In the future, we're going to learn that when things are added or subtracted, when I have, as we'll talk about, we'll call it a binomial, but when I have something different, I can't just apply this power to each one because these things are divided. There's a division line here between just the two numbers that are in there. Or again, because this one's multiplication, this rule works. And same thing with this one. Because it's a division line, I can just apply this 4th power to each thing and get x to the 4th over 7 to the 4th. So that's the second rule I want to show you today. Again, if you're taking notes along with me, write that down. Here is the rule in the red box there. The power of a quotient. Power means, I'm taking something to an exponent. Of a, well, quotient means something that we're dividing. So it's like a fraction or something that's used in division, and we're taking it to a power. Well, then the rule says, if I have stuff that I'm taking to a power here, to like the a power, whatever it is, I can just take each of those things separately to that power. And that works to simplify a problem. So looking at number 3 here, same thing as the ones before. This is y to the third. Now again, this is kind of combining one of the rules we learned from 8.1 with it. This is y to the third, and then that's also to the second power. So that's really y to the third to the second. I can even write like that separately just to make sure you can understand that. Or just to make sure we see that. So that's really that second rule we learned, correct? Just by itself, that's a power to a power. So I multiply 3 and 2 together, I get y to the 6 on the top. And then the x here is it's just x by itself. I could think of it like it really has an exponent of 1, and 2 times 1 would give me 2. So, but either way, it's just like saying, oh, it's x, and now it's x squared when I apply that power to it. So y to the 6th over x squared. Going just through a few other examples here. I think I've got a few of them down here. Number 4, similar. Again, in parentheses, I have 4 divided by w to the 5th. And all that is to the 4th power. So I can just apply each of those things separately to the 4th power. So I can get 4 to the 4th over, and then it's w to the 5th to the 4th power. So I multiply those together, so I get w to the 20th power. Number 5 here. There's just something extra in the parentheses here now, or something extra inside here. We have 2x squared, and then over 3. In one of these, again, all these things are divided, right? And kind of like the example I had at the very top of the page, these are multiplied. And all this is to this 3rd power. So as I'll ask students, well, what do you think will happen in one like this? And after a little thinking, they usually realize, well, that means that every single one of these is going to be applied to the 3rd power. Because when we're multiplying things together, like we said from the previous rule, we have everything to the 3rd power. And now we're finding out when we divide things too, they all go to the 3rd power. So this will become 2 to the 3rd power, x to the 6th over 3 to the 3rd. So every single one of those things goes to the 3rd power. I think I have one more example of that too. So this last one here also. Everything in the parentheses here is to the 4th power. So every coefficient and every variable, because everything is just multiplication or division in here. If there was any addition or subtraction going on, we couldn't do this rule. But because these are multiplied, and then here's division, all these things are combined with products or quotients, I can just take the 4th power to each one of these things separately. So 2 to the 4th power, t to the 4th again. We'll multiply those exponents together again. That's that rule. I'll get t to the 16th, so that's what I get on top. 5 to the 4th power then it becomes, and r to the 3rd to the 4th. Multiply those together, I get r to the 12th. So again, just a brief summary. Here's the 5 rules we learned so far up to this point. And realize again, each rule by itself, not too complex. They're not too tricky, just kind of a one step. But now it's just being able to combine all 5 of these rules. We learned the first 3 here in the first section. We learned these 2 now in 8.2. And now we'll work on using them all together in problems to simplify problems with powers.